Lecture of normalization, we saw that how is normalization useful in designing the good quality databases and how do we determine if the design of our database is appropriate or not. Now before moving ahead on the process of how exactly normalization is done, we need to first discuss some important terms. Let's begin. This would be the major contents of the presentation. Prime versus non-prime attribute. If attribute is a primary key of the given relation, then it is called as prime attribute, otherwise it is called as non-prime attribute. For example, consider the following table with three attributes: account number, balance and branch name. Account number is the primary key and so it is the primary attribute, and other two attributes, that is say balance and branch name, are non-primary attributes. Functional dependency. A functional dependency is a relationship between two attributes within a table. If x and y are two attributes, then functional dependency will be represented by x is to y, which indicates that y is functionally dependent on x. For example, in account table, account number can uniquely identify balance and branch name. So there is a functional dependency from account number to balance and branch name. Definition. For any relation R, attribute y is functionally dependent on attribute x if for every valid instance of x, that value of x determines the value of y. If we try to understand from example, say account number is x, balance is y. Now if I know the account number, I can easily know the balance. So I can say that balance is functionally dependent on account number. Full functional dependency. Consider the following table depositor account with 5 attributes: customer ID, account number, access date, balance and branch name. Customer ID and account number form the primary key. The functional dependency are: access date is functionally dependent on customer ID and account number, balance and branch name are dependent on account number. Here if customer ID or account number is removed from primary key, then access date cannot be uniquely determined. So access date is fully functionally dependent on primary key, whereas the balance and branch name are not. Definition. A functional dependency x is to y in relation schema R is full functional dependency if dependency does not hold after the removal of any attributes from x. Partial functional dependency. A functional dependency x is to y in relation schema R is partial functional dependency if dependency holds even after removal of any attributes from x. As shown in the schema depositor account, balance and branch name are partially dependent on primary key, customer ID and account number, as even after the removal of customer ID from primary key, the dependency on account number holds. Transitive dependency. Consider the following example: a table with 4 attributes, that is say account number, balance, branch name and branch address. Account number is my primary key. I am here considering two main functional dependencies, that is say branch name is functionally dependent on account number, branch address is functionally dependent on branch name. So transitive dependency, account number to branch address holds. Definition. A functional dependency x is to y in relation schema R is transitive dependency if there is a set of attributes z such that z is a non-prime attribute and x is to z. Hello all, I am Chandnisha and today we are going to learn about the process of normalization. These are the major contents of the presentation. Goals of normalization: to minimize data redundancy, to minimize update, insertion and deletion anomaly. First normal form. A relation R is in first normal form if there are no composite attributes, no multi-valued attributes. For example, consider the following schema with columns CID, name, address and contact number. Here address is a composite attribute and contact number is a multi-valued attribute. So clearly this schema is not in first normal form. To convert it into 1NF, we can split the schema as customer ID, name, area and city. That is, say the address, which was a composite attribute, we divided into individual attributes of area and city, and CID and contact number. So the contact number, which was multi-valued attribute, has now been converted into single valued attribute, as shown. As say customer ID C02 had two contact number, so which are inserted in two separate rows, and hence in this way the multi-valued attribute is converted to single value attribute. So now this schema is in first normal form. Second normal form. A relation schema R is in second normal form if it is in first normal form and if every non-prime attribute of the relation is fully functionally dependent on the primary key. Consider the following schema with attributes customer ID, account number, access date, balance and branch name. Here the primary key is the combination of customer ID and account number. Clearly this schema is in first normal form as there are no composite or multi-valued attributes. Now let us check for the second clause. Here the major functional dependencies are access date, balance and branch name are dependent on CID and account number. Balance is dependent only on account number. Branch name is also dependent only on account number. So there are two non-prime attributes, that is say balance and branch name, which are not fully functional dependent on primary key but only on part of it. That is say balance and branch name are dependent only on account number. So clearly this relation is not in second normal form. To convert schema in second normal form, split it in such a way that partial dependencies get eliminated. So we split the schema as account number, balance and branch name, customer ID, account number and access date. So partial dependency which existed in earlier schema has now been eliminated. Third normal form. A relation R is in third normal form if it is in second normal form and if no non-prime attribute of relation is transitively dependent on the primary key. Consider the following schema: account number, balance, branch name and branch address. Here clearly it is in first normal form and second normal form. Now let us check for the second clause. The major functional dependencies here are, see branch name, it is dependent on account number and branch address on branch name. So we can say the transitive dependency branch address to account number holds. Hence this transitive dependency on primary key has to be removed to convert the schema into third normal form. Split the schema in such a way that there is no transitive dependency on primary key. So if we split it as account number, balance and branch name and address, there would be no transitive dependency on primary key. Boy's code normal form. A relation schema is in BCNF if it is in 3NF and no prime attribute of relation is transitively dependent on primary key. Consider the following schema: student, language and guide. Here the primary key is formed by student and language. The functional dependencies are guide can be determined by the group of student and language can be determined from guide. So transitive dependency student language to language holds. Hence this schema is not in BCNF. To convert it into BCNF, we need to remove the transitive dependency on the primary key. So if we split the schema as schema 1 student guide and schema 2 guide and language, it will get converted to BCNF. Please note that there is very small difference between 3NF and BCNF. 3NF says that every no non-prime attribute should be transitively dependent on primary key, whereas BCNF says that no prime attribute should be transitively dependent on the primary key. These are the references. Thank you.